What's good, Logan? So here's another Algebra 2 video on graphical analysis, focusing primarily on the polynomial function. The first question is, what is the degree of this polynomial? And when you look at it, you'll notice that the end behavior, right, on the right side of the graph, it is going up, and on the left side of the graph, it's going down. We'll talk more about how to write that out explicitly, but that right there indicates that it's going to be odd. So we know that we have an odd degree polynomial. All right, so we have an odd degree polynomial, and then the next thing is noticing that that is traditionally the positive location, the positive directions. We're going to say that is the lead coefficient is positive. Some people ask, how do I know that? Well, the odd and positive looks like this. That's the end behavior. But if it was negative, right? So if it was odd and negative, this would switch to go down, it would reflect, and that would switch to go up, which is not what we have here. So we can confidently say that it is odd and has a lead coefficient that is positive. Let's move on to the increasing and decreasing. Question C, where is the function increasing and decreasing? In other words, what values of x is f of x increasing or decreasing? So this is what I'm going to do. This is the strategy that I take. I like to graph different colors based upon what's going on. And I look at the graph from the left side, so I'm going to start at that bottom left arrow, and I'm just going to highlight the graph and just ask myself, am I increasing or decreasing? And if it's continually the same word over and over, if it's always increasing, I'm going to keep the color. But the moment it changes, I'm going to switch it. Let me show you what I mean. So I start right here and I'm like, all right, well, I'm increasing. The function is increasing. I'm going higher and higher. I am increasing. I am increasing. I am increasing. And no, I'm not increasing anymore. All right. So what I should have done is once I got up to that point where it starts to turn, right, also known as the turning point, I should have changed colors. I should have said, oh, now I'm decreasing. Okay, so now that I'm decreasing over here, I recognize that once I get to this point, I stop decreasing, right, and I turn. I start to increase again. So now I'm increasing and I continue to increase for the rest of the functions, for the rest of the graph. This right here indicates using colors where the graph is increasing and where the graph is decreasing. So the first thing I'll do is I'll just kind of highlight it to get a sense of where is the function increasing versus where is the function decreasing. The next thing I'm going to do is I'm going to go to my turning points. So let me indicate that. I'm going to go to my turning points and I'm just going to indicate on the x-axis. So I'm going to make dotted lines on the x-axis, right there, on the x-axis, where it changes from increasing to decreasing. And I'll do the same thing on this turning point over here as well. Now those arrows are just for me. It's not anything you have to write down. It just helps me understand that those x values where we start to change. It's where we turn from increasing to decreasing or decreasing to increasing. The next thing I'm going to want to do is I want to indicate what those values are. What are the x values there? So I count -1, -1, -2, -3, -4. So I'll put a -4 over there. All right. So now after I've done that, so step number 2, kind of, find out on the x-axis, what are these numbers? Now I'm just going to label for each of the segments, not segments, sorry, for each of the regions, whether or not the function was increasing or decreasing. So on the green one, that's where we said it was increasing because it was going upwards. So we're going to say f of x, right? Our function f of x is increasing. Okay, I'm going to abbreviate that. And over here on this one, right, on this one, you'll notice the function is decreasing. So I'm going to say that f of x is decreasing. F of x is decreasing. And we'll abbreviate that as well. And then finally over here, you'll notice that the function goes back and starts to increase again. So in this region, we'll say that f of x is increasing. That's my third step. Oh, I didn't abbreviate that. All right. So my third step is to identify within which regions what's going on, right? So in the first region, f of x is increasing. In the second region, f of x is decreasing. And in my third region, f of x is increasing again. Now what I want to do, and this is pretty much the final step right here, is I want to say what are the x values in which that occurs. So how would you define that region? Now, this is old school. So if you think about it, you could use that whole number line thing from back in the day, and you could say, starting here, and moving in this direction, that's where it is increasing, all right? Now, if you don't like that, that's fine. You can just say, oh, all these values to the left, all these values here, so this right here, that's where x is -5. This right here, that's where x is -6. And you'll notice that I started at -4 and I went -4, -5, -6, -7. In other words, I am talking about all the x values that are less than -4. And this statement, f of x is increasing, f of x is increasing when x is less than -4 is me answering what values of x is the function increasing. It is increasing for all the x's less than 4. And I can do the same thing for the decreasing. The decreasing is a little bit more complicated. So I'm going to skip that. I'll come back to it right after. I want to take a look at the f of x is increasing. I'm not saying that increasing is always easier, but the n values have much simpler inequalities. So this one over here, you'll notice that, oh, this is -1 and this is 0, and this is 1, x is 2, x is 3, x is 4. So you'll notice that all the x values here are greater than -1. That's when we get the green part of the graph. So you can say that f of x is increasing when x is greater than -1. So these two guys right here, these two guys together identify when the function is increasing. And then now for the more complicated one, which isn't too bad. It's not too bad. It's kind of goofy, but it's not too bad. It gets easier as you do more of it. What you want to say is that f of x is decreasing between the two numbers -4 and -1, right? Now, mathematicians are notorious for being lazy. So when we say the word -4 is between, sorry, x, the numbers are between, x is between -4 and -1, what we write down is this. We're going to write down the two numbers we're between, -4 and -1. And then we're going to use inequalities to indicate that the x value is between them. And that's how we would write this. So this right here, I know it looks like it says -4 is less than x is less than -1, but when people say that, they don't know what they're talking about. What I encourage you guys to say is that is between x is between -4 and -1. That way you get a better understanding of really what's going on here. And this are the x values for which the function f of x is decreasing. So f of x is decreasing when, and listen to what I'm going to say, when x is between -4 and -1. And this answers this piece. So this is how we would answer, this is how we would analyze our polynomial functions as far as increasing the intervals and decreasing intervals is concerned. If you have any questions, go ahead and send me an email, and I'll get back to you as soon as possible.